All right, on page 371, today we're going to be talking about inequalities. In two triangles. And what you're going to be doing is comparing angle measures and side lengths in two different triangles. So this theorem on page 371, it's called the hinge theorem. And it's kind of wordy, but it does explain what you're going to be doing. And I'll try to condense it the best that I can. And we're starting with if two sides of a triangle are congruent, to two sides of another triangle. And the included angle of the first triangle is larger than the included angle of the second triangle. Then the third side of the first triangle is longer than the third side of the second triangle. And this diagram will make a lot more sense. But again, if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So here's what this looks like in a picture. We use the same two triangles that they have in the theorem. And we've got triangle ABC here. And we've got a second triangle, FGH. Now, what the theorem said is that two sides of one triangle are congruent to two sides of another triangle. The included angle, remember guys what the included angle is. It's the angle that is formed by the two congruent sides. So the included angle here is going to be angle A in the first triangle. And if we put a 43-degree measure here, and the included angle in the second triangle is angle F. And let's give it a 30-degree measure. So we've got two sides of one triangle congruent to two sides of another triangle. The included angle of the first triangle is larger than the included angle of the second triangle. What the theorem said is that the third side of the first triangle, so side BC, is going to be longer or greater than side GH. Hopefully everybody can see that and that it makes sense based on what we did last week when we ordered the sides of triangles based on their opposite angles. All right, so two sides of one triangle congruent to two sides of another. You have to have that. You have to have included angles. If you have two congruent sides and included angles, then you can compare the angles, and that will allow you to make a statement about the third side lengths. See it? So then let's look at two different triangles. Let's take a triangle MNO, and then right next to it, a very similar to it, triangle XYZ. Let's go with two sides of one triangle congruent to two sides of another triangle. Now the included angle in this first triangle is angle N. Let's make it 40 degrees. And let's make the included angle in the second triangle 41 degrees. If you had to compare now, if you had to compare MO, you're going to compare it to XZ. What is the comparison? And when you're asked to compare, in this case, when we're talking about inequalities in two triangles, compare just means less than or greater than. All right? MO is going to be less than XZ. And if you had to explain, it could be because angle N is less than what? Angle Y, good. And then what would happen if both of these angles, if angle N was the same measure as angle Y? Then MO would be equal to or congruent to XZ, wouldn't it? Okay? All right. So then, in that case and in that example, we were comparing side lengths. The second part, or the converse of the hinge theorem, allows you to compare angle measures. So let's get this theorem in your notes as well. This is the converse of the hinge theorem, and it states if two sides of a triangle are congruent to, let's use the congruent symbol, two sides of another triangle, and the third side in the first is longer than the third side in the second, then the included angle in the first is larger than the included angle in the second. So this is the theorem that you would use if you were asked to compare angle measures. So let's take something like this quadrilateral. We'll label it ABCD. We'll put a diagonal through here. Side AB is 4. I'm sorry. Side AB is congruent to side CD. Side AD up here is 4. And side FD is 3. And we have to compare angle ABD to angle, if we're going ABD, then we're going to go CDB. So let's look at the angles we're comparing. We're going to compare this angle to this angle. Look what we got. We've got Side AB and side BD in the top triangle. See how side BD is in both triangles? So it's the same in both triangles. So in this top triangle, we've got two sides congruent to two sides of the bottom triangle. Now we're looking at the third side of the top triangle. The third side of the top triangle is 4 units long. And the third side of the bottom triangle is 3 units long. And we have to compare the third angle measure of the top to the third angle measure of the bottom. What's the comparison going to be? Let's just call this angle B right here, compared to angle D. Greater than, less than, or equal to? Let's look at the third side. This third side is 4. This third side is 3. Which angle is going to be bigger? ABD, right? The angle opposite the longer side is going to be bigger. So angle ABD is greater than angle CDB. All right, let's take a look at one more of these. Let's look at this picture. All right, R to S is 8, and S to T is 6. R to V is 8. V to T is 11. And we've got to compare angle SRT and angle VRT. SRT and VRT. So I'm going to highlight those again. SRT is right here. And then we've got VRT, which is right here. So we've got in this top triangle, we got a side that's 8. And look at the side that they share. The two triangles share side RT. So side RT is the same in both triangles. Now, in this top triangle, we have a side that's 8. And in the bottom triangle, we have another side that's 8. So we've got two sides in one triangle congruent to two sides of another triangle. So if we have to compare these two angle measures, we have to look at the third side. So look at this third side and compare it to this third side. Isn't the third side of the top triangle smaller than the third side of the bottom triangle? All right, so what does that make angle SRT compared to angle VRT? Less than, very good. All right, so any questions on comparing angle measures in two triangles or comparing side lengths in two triangles using the hinge theorem? All right, then your practice today is going to start on page 375. 1 through 5, and then 10 through 15. Please be sure that you continue to check your odd answers in the back of the book as you're doing the assignment. And if you have any problems, please come see me.